Hi, my name is Zorla Shane Lakab. I am a student from Kent, and welcome to my YouTube channel. So this channel is basically just for the submission of my tutorials in cloud and beyond. And for today's video, or for this week, we were breaking down cloud computing, what it is, the 5 characteristics that define it, the benefits, the key roles in the ecosystem. So let's get into it. So the formal NIST definition says that cloud computing is a model for enabling on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal effort. So that's a lot of big words to digest. But if we explain cloud computing on the simplest form, it's like renting computing power over the internet. So that's like the basis of it. But if we use analogy, maybe we can understand it more. So before the electrical grid existed, every factory built its own power generator, so that's expensive and complicated. Then the centralized power grids came along, so you could just plug in and pay for what you consume. So cloud computing is the same as electric utility. So you only use what you need, and you don't need to know where it came from, or the electricity, or like what is happening on the power plant. You just need to plug in and enjoy your electricity. So now we will describe the 5 characteristics of cloud computing. As I said before in the NISE definition, that's the gist of it, but I will delve deeper more and maybe disseminize everything. So we have 5 characteristics of cloud computing. First one is on-demand self-service. So you can get resources whenever you need them without calling anyone. You can just log into the dashboard, click, and boom, you got a new server. It's like shopping online. You don't need to call Amazon to place your order. You just like browse on your phone, click, check out, and done. So cloud infrastructure works the same way. Next one is broad network access. So cloud services work from any device. Maybe it's a laptop or phone, a tablet. So if you start a Google Doc on your laptop, but then again you need to go and you switch phone and you're using it on a train. So you can pick up exactly where you left off. So the computing happens on the server side and your device is just a window. So you can use it from any devices. You can access it whenever or wherever. Next one is resource pooling. So the provider pools all the resources, processing, memory, and storage, and shares them across multiple customers. So it's called like multi-tenancy. So if I were to compare again, another analogy is that the building that we use in Kent, the Queen Street building, I forgot the number, but there are many floors, and each floors have many different offices. So we use the same building infrastructure, we use the same space, address, utilities, and stuff, but every building is secured and have private space based on what they need. And that's is resource pooling. Next one is rapid elasticity. So you can scale up resources when you need them and put it down when you don't. So if you run an online store and in a regular Tuesday you have 5,000 visitors, but on Black Friday or any like sale, end of the year sales and stuff, you'll get like 500,000. So cloud auto scales to handle the spike, then shrinks it back when it doesn't need it. So you only pay for what you use. There's no wasted capacity, there's no crashing. And yeah, last one is the measured services. So everything is metered, everything is taken note of. The storage, compute bandwidth, you are built exactly for what you consume. Just like your electricity bill, you can see your kilowatts and how much you need to pay for it. And yes, we now go to benefits of cloud computing. Everyone is moving to cloud, and I can think of like 4 basic big reasons on why every company, every organization is moving to cloud. And the number one is money, cost. Because it is cost efficient now that we're using another infrastructure to run it on our own. You don't need to pay for infrastructure. You don't need to pay for data warehouse, storage, and stuff. You can use it. You can use it from cloud providers. Next one is scalability. So you can scale it down if you need it. You can still scale it up if you. Oh no, if you can still scale it down if you don't, then scale it up when you need. It's like this is what I have discussed before. And availability. So your data is replicated across multiple data centers in the world. So what happens if the Melbourne server goes down? There's still Sydney, there's still maybe Taipei that you can rely on. So that guarantees 99.99% uptime. So I know uptime because I'm currently studying Azure fundamentals and we told deeper about uptime and cloud regions. Next one is agility. So if you need an new server at all times you need to order it, but now you can just do it on cloud in like minutes. Now we will go to cloud roles. And to simplify it further, I will use a mall analogy. So in NISC references, we have five roles in cloud ecosystem. And I will use the mall analogy to make it safe. There's a mall near me called Fountain Gate, and I will use that as a reference. So the cloud provider is the landlord. They own Fountain Gate. They own the building. They maintain it. They lease out space. So that is our AWS, Azure Cloud, Google Cloud. So they operate the data centers and deliver services under SLA guarantees. Service level agreements. This is very important as a cybersecurity student. So SLA outlines what is the cloud provider providing you so that you have like a mutual understanding of what should be received, what are you responsible for in case of something happens. And now we have the cloud consumer. So they are the tenants. So they renting the space. But here's the key. So as I said, I'm studying Azure fundamentals and there's a shared responsibility model. So either if it's like infrastructure as a service, software as a service, um, and platform as a service, they all have responsibilities on the data that they use. So the provider secures infrastructure of the cloud, which is the hardware, network, and facilities, but the consumer secure what it's in the cloud, the data, the access control, and configurations. So most cloud breaches happen because consumers misconfigured something, so not because the provider got hacked. So that's some massive differences that we need to know. The next one is the cloud auditor. That's like a health inspector. They're like independent third party who assesses the security, privacy, and performance. We can, on cybersecurity terms, we can think of it as like the SOC 2 audits, ISO 27001 certifications. So their job is to build trust between provider and consumer. So if your organization is stamped with this, oh, I got certifications that says my cybersecurity is on point. So the consumer basically will trust me. Next one is the cloud broker. So they are like real estate agents, the middleman. So they help consumers find and negotiate the best cloud services. So they do this through intermediation, aggregation, or arbitrage across providers. So they compare the prices and make sure the consumer gets what they actually need from the cloud providers. Next one is the cloud carrier. So it is the road connecting the mall to your house. Basically, this is the ISP. So this is your telcos, internet service providers. Because if you have no internet, you have no network, you definitely have no cloud. And that network quality directly impacts performance. So if you have like a low signal, low connection, you cannot access the cloud. So if I will just recap, cloud computing, IT delivered as a utility. There's a five NISC characteristics: self-service, broad access, pooling, latency, measured services. Benefits: cost, scalability, agility, and availability. Five roles: provider, consumer, auditor, broker, carrier. And we need to remember the shared responsibility model. So the provider secure the cloud and you secure what's in it. So that's it. I hope I explained fully what I understand about cloud computing for this week lessons on cloud and beyond. Ciao.